Hello, Accelerated Chemistry. This is Miss Crisafoli, and this is your Chapter 15, Section 1, video notes all over water and its properties. So let's talk about water in the liquid state. So water is a simple molecule consisting of three atoms. It has an oxygen atom that forms covalent bonds with two hydrogens. Remember, oxygen has a greater electronegativity than hydrogen, so the oxygen atom is going to attract electron pairs in the OH bond a greater amount than the hydrogen does. So that makes that OH bond polar. The oxygen atom is going to acquire a partial negative charge because remember, all of the electron density cloud is going to be on that oxygen. That means that the hydrogens are going to have a partial positive charge because they don't have those electrons to keep them neutral anymore. That electron density got pulled towards the oxygen. So how do the polarities of the two OH bonds affect the polarity of the molecule? This should be a review. Remember, the molecule has a bent shape. That means that we started off as a tetrahedral because we had 4 electron groups around the central oxygen. 2 of them are going to be bonded. 2 of them are not going to be bonded. So that's why we have a bent shape. The 2 OH bond polarities are not going to cancel out. So the water molecule as a whole is going to be polar. In general, polar molecules are attracted to one another by dipole interactions. Remember, dipole-dipole intermolecular forces happen between 2 molecules that are polar. The negative end of one molecule is going to be attracted to the positive end of the other molecule. The attraction between molecules results in hydrogen bonding for water, though, because hydrogen bonds are attractive forces that arrive when a hydrogen atom is covalently bonded to an electronegative atom and also weakly bonded to an unshared pair of electrons on another electronegative atom. Remember, hydrogen bonds only occur between nitrogen, oxygen, and fluorine. And those nitrogen, oxygen, and fluorines have to already be bonded to a hydrogen atom. Hydrogen bonding is the reason why water has the following properties: high surface tension, low vapor pressure, and a high boiling point. So let's talk about surface tension. The water molecules within a body of the liquid form hydrogen bonds with the other molecules surrounding them on all sides. The attractive forces on each of these molecules are balanced. So what that does is that it allows for the water molecules at the surface of a liquid to experience an unbalanced attraction. And as a result, the water molecules at the surface tend to draw inward. That's why we see water bubble up on the hood of cars, leaves, countertops, because that hydrogen bonding is so strong between the water molecules, it's going to pull them all in towards each other. Now, that inward force or pull that tends to minimize the surface area of a liquid is called surface tension. So it is possible to decrease the surface tension by adding a surfactant. A surfactant is any substance that interferes with the hydrogen bonding between water molecules and thereby reduces surface tension. Soaps and detergents are what we call surfactants. Let's talk about vapor pressure. Hydrogen bonding between water molecules also explains water's usually low vapor pressure. Hydrogen bonds hold the molecules of the water close to one another, and these hydrogen bonds must be overcome before water changes from a liquid to a vapor state. So the tendency of these molecules to escape is low, and that means your evaporation is also going to be slow. Talk about the boiling point. There is a difference between boiling points of ammonia and water due to hydrogen bonding, which is more extensive in water than in ammonia. It takes much more heat to disrupt the attraction between the water molecules than it does between the ammonia molecules. Now let's talk about water in the solid state. We know that ice cubes float in your glass of iced tea because solid water has a lower density than liquid water. But this is not true for all liquids. As water begins to cool, it behaves initially like a liquid. It contracts slightly and its density gradually increases. When the temperature of the water falls below 4 degrees, the density of the water actually starts to decrease. Below 4 degrees, water no longer behaves like a typical liquid. Ice, which forms at 0 degrees, has about a 10% lower density than water at 0 degrees. Ice is one of only a few solids that will float in its own liquid. So why does it have a density that is less than liquid water? Well, the structure of ice is a regular, open framework of water molecules in a hexagonal arrangement. The hexagonal symmetry of a snowflake reflects the structure of the ice crystal. So what happens is that the extensive hydrogen bonding in ice holds the water molecules farther apart in a more ordered arrangement than in liquid water. These holes in its structure allows for it to have a larger volume. Remember, density is mass divided by volume. So if you have a larger volume, your density is going to be smaller if you have the same mass of water. So the fact that ice floats is important consequences for all organisms. So the liquid at the bottom of an otherwise frozen body of water is warmer than 0 degrees. So that's why aquatic life can survive. If ice were denser than liquid water, the bodies of water would tend to freeze solid during the winter, and that means that a lot of different organisms that survive in water would no longer be able to survive in colder temperatures. Well, this is the end of your Chapter 15 Video 1 notes, and as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition textbooks, resources, CD, and pearsonchem.com. Thank you so much. Have a good night.